Math 6, Module 6, Lesson 5, describing a distribution displayed in a histogram. Students will construct a relative frequency histogram, and students will recognize that the shape of a histogram constructed using relative frequencies is the same as the shape of a histogram constructed using frequencies, provided that the same intervals are used. So, thing to remember here, relative frequency is the same of a regular frequency, okay, when we're talking about the shape of the histogram, if they use the same intervals. Okay, so example 1, relative frequency table. In lesson 4, we investigated the head circumferences that the boys and girls basketball teams collected. Below is the frequency table of the head circumferences that they are measured, and we have it. There's the chart. Isabel, one of the basketball players, indicated that most of the caps were small, medium, or large. To decide if Isabel is correct, the players added a relative frequency column to the table. Now, what is relative frequency? That is the frequency for an interval divided by the total number of data values. Total number of data values. Okay, for example, the relative frequency for the extra large cap is 2, frequency 2, divided by the total here, 40. And that is equal to 0.05. And how do we get that? We just divide it. Remember, go from a fraction to decimal, you just do what it says, 2 divided by 40. This represents a fraction of the data values that were extra small. So there's only 5/100ths of the values that are extra small. Now, example 1. It says, in lesson 4, here's the circumference chart again. Okay, so it's the exact same thing from the first page. Now, what does the frequency, or 15 in the frequency column, so right here, whoops, 15 in the frequency column, what does that represent? So how many counts would need to be ordered? So what does that even mean? Right there, that 15. Well, the 15 in the frequency column represents the number of people who had the head circumference in the interval of 550 up to 570 millimeters, not including 570 though. Notice that it's 550 to less than 570. Therefore, 15 size medium caps would need to be ordered. So, how could we determine what fraction of total number of medium-sized caps? Well, what's the fraction? We would have 15 over 40. Right? We can determine by dividing the number of caps by the total number of caps ordered. There are 2 people in the extra small cap size interval, which is a head circumference of 510 to 529. The relative frequency for the interval is 2 divided by the total number, 40. And we got this number whenever I showed you that earlier, or 5%. Notice whenever we go from fraction to decimal, then we can just move the decimal place 2 places and we would get our percentage. Y'all should know this. So the interval from 530 to 549 millimeters, the frequency is 8. We have that right here. So we would do 8 divided by 40, and we know that is 1/5, because 8 will go into both of those. And we know that 1/5 is 0.2 or 20%. Remember I told you need to know those fifths. Now, how do you find the total number of the data values? So what if this was not here? What if the total was not given? What would you do? all you have to do is just add up all the frequencies. Okay. In order to find the total number of data values, you add all the frequencies together. Like I said, add the frequencies. What will the sum of the relative frequency column be? Now, if we do a relative frequency column, which we're about to do, so this would be relative frequency. And if we take all of these, like here we had 0.05, here we have 0.2. What will all of those add up to be? Or just think about this. We have 15 plus, not 40, 15 40ths plus 8 40ths. What would that end up adding up to be? Well, it should add up to 1. If you add all these up, they should add up to 1. The sum of the relative frequency column will equal 1. What is the difference between a frequency table and a relative frequency table? Okay, frequency table and relative frequency. The frequency table shows the actual number of counts that needs to be ordered in each size. The relative frequency table shows the relative frequency for each size that needs to be ordered. So how are the two types of tables similar? Well, for example, both types of tables list intervals of possible data values and describe how the data values were distributed into these intervals. Remember, these are the intervals over here. Okay. So complete the relative frequency column in the table below. We did these two. Now, all we would do is take 15 divided by 40. All these are just divided by 40. So 15 divided by 40 is 0.375. 9 divided by 40, 0.225. 4 divided by 40, well, we could reduce that to 1 over 10. Well, that's 0.1 or 1/10. And we've already done 2 out of 40. Notice that this right here also equals 1 or 100%. So what is the total of the relative frequency column? Once again, that is 1 or 1%. Which interval has the greatest relative frequency? Okay. Which one has the greatest relative frequency? Well, this has the greatest relative frequency. And what is because it's the most, right? So the interval with the greatest relative frequency is the medium size count right here. That's the interval. Now the value is 0.375, and that's the relative value. I'm sorry, relative frequency. That's the value. So what percentage of the head circumferences are between 530 and 589? So 530 is here to here. 530 to 590 there. So it says what percentage of the head circumferences are there. So all you would have to do is take the relative frequency and add them up. If you add all of those up, that's the number you get, but we wanted the percentage. So we would move that 2 places to the right, and we would get 80%. Okay. So they decided to construct a histogram using the relative frequencies instead of the frequencies. They noticed that the relative frequencies in the table range from close to 0 to about 40 hundredths. They drew a number line and marked off the intervals on that line. Then they drew the vertical line and labeled it relative frequency. They added a scale of this line to be starting at 0 and counted by 500ths until they reached 40. 500ths to 40. Now, they completed the histogram by drawing the bars so that the height of each bar matched the relative frequencies of that interval. Here is the completed relative frequency histogram. Now, what do you notice about the shape of the center of the frequency histogram and the relative frequency histogram? Okay. So, the shape and the center. Well, I think it's easy to say that the center be somewhere around in here. And what is the shape? If we looked at that, we would say that they are about the same, because if we looked at the one, we didn't have a frequency one. I don't think we have one. Okay. So we don't have the frequency, we only have the relative frequency, but they're going to be the same. And remember, if we go all the way back to the very first, and I said the students recognize that the shape of a histogram constructed from using relative frequencies is the same as the shape of the histogram constructed using frequencies, provided that they have the same interval. And right there. So without even drawing it, we should know that they are the same. So what's the greatest number that could be on the vertical axis in a relative frequency histogram? So over here, what would be the highest number that could go right there on any of them? Not just this one, but on any of them. Remember, what did we say that that total would be? It would have to be 1, right? It can't be higher than 1. That would mean you have more tally marks than you do actual numbers of people, like in the hat situation. So what is the relative frequency for large count size? Well, we don't know from here. We're going to have to go back and see, well, what was the large count size? Large count size is between 570 and 590. So right here would be 570 and 590. It would be this histogram bar here. And so we would say that's about 0.23, which means about 23% has or needs a large cap. That's how many you would need to order so that they could wear a large size cap. All right, page 5. Here's a histogram of the head circumference. So it's still working with the same data. Exercises 5 and 6. Describe the shape of the relative histogram, frequency histogram, of the head circumferences of example 2. So that would be the shape. And they say that the shape of the relative frequency is slightly skewed right. So whenever we talk about skewed, you're either going to have a mound shape. I'm trying to draw that a little bit better, which is symmetrical, or you're going to have a really long tail right there, and this is skewed right. Or you could have one that looks like this, where it's skewed left. Now, this can be a little bit confusing. So the way I talk about it, when we're talking about skewed right, I talk about it as far as climbing up a ladder. We're going to climb up the ladder on a slide, and we're going to slide down to the right. So here you're going to climb up the ladder on the playground, and then you're going to slide to the left. You're going to slide off to the left. So that's what's happening here. We go up the ladder, get to the top, and we're going to slide down to the right. Okay, so which way are you sliding? That's the way I try and imagine it. Now, this one is slightly skewed right. Slightly. Very slightly. It's almost symmetrical, but we would call this slightly skewed. How does the shape in the relative frequency histogram compare to the frequency histogram you drew in exercise 5 of lesson 4? So if you go all the way back to lesson 4 in exercise 5, and you think about it, let's think about it. We should know just from what we were told we would learn that they should be the same, right? Whether it's frequency or relative frequency here, as long as we use the same intervals, then they should look the same. The shape should be the same. So Isabel said that the most of the caps that needed in order to be ordered were small, medium, and large. Was she right? What percentages of the cap to be ordered were small, medium, large? So this is small, this is medium, and this is large. Well, we can look and see that most of our numbers come here. So let's just do for sure. That is 0.20. I think we said 0.23 for this one. And let's call that we'll say 33. No, 38. I'm sorry. 38. That's 1. Carry my 1. 36. That's 81/100ths or 81%. So yeah, that is easy to say. They got 80. They only did. This is 37. But that's close just by looking at it. It doesn't matter. It doesn't have to be exact. But yeah, that would be the majority of your, there's only 20% left or 19% left, whichever one you're looking at. So the majority of them are small, medium, and large. So here's the frequency table of the seating capacity of arenas, which is like the stadiums of NBA basketball teams. So come over here to A, right here. It says, what is the total number of basketball arenas? Now, how are we going to get the total number? Remember, all we have to do is add up our frequencies. And if we were to add those up, that would be 29. There are 29 NBA arenas. Okay. B says, complete the relative frequency column. Round the relative frequencies to the nearest thousandths. So let's do that. We would have 2 divided by 29, 1 divided by 29, 6 divided by 29, 5 divided by 29, and so on, right? We would just do that every time, and we would get all these numbers. Okay. I'm not going to sit there and divide those and show those to you. You should be able to do every one of those and get those answers. Now it says construct a relative frequency histogram. So if you look, just think about, we know that our intervals are going to be the number of seats here, right? That's going to be our X. That's going to be the bottom. Now the vertical, we're going to have to use these relative frequencies. Well, let's look at our highest frequency. It's 207 thousandths, 207 thousandths. So what are we going to make our intervals be of relative frequency? They did 500ths each. Here's 500ths, and then 10 hundredths, 15 hundredths, 20 hundredths, and 25 hundredths. And that includes all of our frequencies. So if you were to graph those, 0.69, so there's 0.06, there's about 0.7, so there's our 0.69. And we would just plot those. Okay. Notice there's nothing in between 21 and 22 because there are 0 seats there. Okay. Now, let me clean up some of this. And now it says describe the shape over here for D. How would you describe that shape? So the best way to do it is just to draw it. We'd probably say that is skewed right, slightly skewed right. And it is. Climb up the ladder, slide to the right. E. What percentage of the arenas have a seating capacity between 18,500 and let's just call it 20,000? So when you look at the easiest way to do this is going to be look at your chart, not necessarily looking at your histogram. It's easier to read, I think. So 1850 would be here to 20,000 would be here. So it's these 3 rows. Oh, and look, they're all the same. So we could say 0.172 times 3, and that's going to give us approximately 0.516. Or, we move our decimal place 2, we have 51.6%. Notice that that's 51.6% capacity between 18,500 and 19,999 seats. That's how you would explain that. F, how does the relative frequency histogram compare to the frequency histogram that you drew in problem 2 of problem set in lesson 4? So if you think back to it, if they use the same frequency of number of seats, the same intervals here, it should be the exact same. As long as they use the same intervals here, this has to be the same. There's no change in that. So as long as they use the same down here on the bottom for the relative frequency and the regular frequency, as long as they use these same values down here, it's going to look the exact same. Okay, that's it. Now, a lesson summary, this is what you need to know. A relative frequency is the frequency of an interval divided by the total number of data values. We know that. We just take our frequency and divide by the total number, right? For example, if the first interval contains 8, so we have 8, and the total is 32, we would get 1/4 reduced, so that is 0.25 or 25%. A relative frequency histogram is a histogram that is constructed using relative frequencies instead of frequencies. Look, relative frequency histogram. It's the only difference.